Okay, everything is working on your side. You are broadcasting your screen, so we can start. First of all, Ruben, thanks a lot and welcome along to our masterclass. We are all delighted to have you among us this afternoon to address the issues of decentralization of the web and linked data publishing and requiring. Before we let you jump in, we would like to introduce you, to quickly introduce you for those who don't know you yet. So Ruben Taelman, you are a web postdoctoral researcher at ID Lab, namely the Internet Technology and Data Science Laboratory of Ghent University in Belgium. Your research touched upon the decentralized publication and querying of linked data on the web, and investigating the trade-off that exists between server and client. You advocate openness of the data on the web. You say, and I quote, "My goal is to make data accessible for everyone by providing intelligent infrastructure and algorithms for data publication and retrieval." So through your research, you have been involved in the development of software and tools, among which Solid, that you are going to tell us about. So I think I'm done with this tiny introduction. Now the floor is yours.
Right. Thanks a lot for the introduction. Now, before we dive into the actual presentation, let's just very quickly start off with a single slide where I'll try to give a very high-level description of what Solid is, and then we'll zoom in on everything in more detail in the rest of the presentation. So Solid, in a couple of words, is a web-based decentralization ecosystem where users are in full control over their own data, how it's stored, how it's managed, and so on. Solid is based on open standards, and all of these standards are compatible with the current web technologies. So don't worry if this still is a bit vague, but we'll zoom into everything in more detail later. So this presentation will be split up into three main parts. In the first part, we'll have a look at the what some of the original motivations for Solid are and some of the history behind it. Then in the second part, we'll have a look at how Solid actually works without going into too much of the technical details. And then in the final part, we'll have a look at some of the next steps for Solid and what some of the open challenges are. But let us start off with the history behind Solid. So to capture the history, we have to go back all the way to the year 1989 to CERN in Switzerland, where this guy here, Tim Berners-Lee, invented the World Wide Web. So as you probably already know, CERN is this famous research institute in Switzerland, which is known for a lot of things, such as the Large Hadron Collider, and also discovering the Higgs boson particle and so on. But around the year 1989, Tim Berners-Lee was working there, and he was tasked with the job of finding a solution to the data management problem at CERN. Because the thing is, back then, they, like most research institutes, they had a lot of different computers from a lot of different vendors. Like they had a bunch of IBM computers, some computers by Compaq, some by Dell even perhaps. And the problem was, back then, it was really difficult to get like an overview of all of the data that existed from across all of the experiments. And this was because the computers were from different vendors, and these computers were really difficult to be made interoperable. So Tim Berners-Lee had a proposal for this problem, and he wrote this proposal down in this paper called Information Management. And in this paper, he proposed a system where data could actually be linked to each other via hyperlinks across different computers, so that this collection of data and links could be seen as like a web of data, and you could use these applications called web browsers to follow links across this chain of data to visualize all of this data. So for us, if we hear this description, it becomes clear that this is like the web as we know it today that he is describing. But back then, since the web did not really exist yet, it was difficult for people to imagine what this actually meant. Like on the top of this paper, you can see the famous sentence that his supervisor wrote down, vague but exciting. So he found the idea interesting, but a bit vague. But nevertheless, the ideas eventually took off and led to the web as we know it today. Now, the most important concepts that are foundational to the web as it is today were described in this paper. And on this slide, I quickly summarized what the most important of these concepts are. So the first one, I already mentioned it to you, data can be linked to each other across different systems. And an important side note to that is that decentralization is really a crucial concept within the web, where you could start off with a bunch of systems that are linked to each other, but you can hook up any new system at any point in time without having to register to like a centralized computer that has like an overview of all of the other computers. So the web, in essence, is non-centralized. Then another important element in here is browser software, because if you have a lot of this interlinked data, it can be difficult for people to make sense of all of this data. So you need software called browsers to be able to visualize this data and also to be able to navigate hyperlinks to other pages on the web. Then a third foundational idea is the ability where everyone can read and write data. So web browsers originally were not only supposed to visualize data on the web, but they were also able to actually edit data. And then finally, the web is based on open standards, which means that anyone who is willing to do it can implement tools on the web, such as web browsers, without having to ask permission from anyone. So yeah, these are like 4 of the most important foundational ideas in the web. Now, as you know, the web eventually became worldwide. So it started at research institutes such as CERN, but then it quickly grew to other companies as well. And then eventually individuals like us also became part of the web. Now, another important part of the history of Solid that I want to tell you are the so-called browser wars. So as I've mentioned 2 slides ago, since the web is based on open standards, anyone can implement their own software, such as web browsers. So eventually, different web browsers were actually implemented by different companies and organizations. And of course, every web browser wanted to have as large user adoption as possible. So they heavily competed against each other to have like the best user experience, the best features, and so on. And the thing is, everyone kind of agrees that the browser wars ended around the year 2017, which was around the time where the browser Chrome from Google, was largely the most popular web browser by far. And it actually still is up until this day. Now, I won't talk too much more about the browser wars. The only thing I wanted, well, the only reason I wanted to mention this was because during this heavy competition of the browser wars, something very important got lost from the web's foundational ideas. And this was the write part. Because the thing is, the very first web browser that was implemented at CERN was actually also an editor. So the web was originally envisioned as really to be a collaborative space. Now, the web browsers that came after it, they actually took out this write part because most of them considered it too difficult to implement. Because the thing is, if you want to write or edit, you need a way to represent permissions and identity in a decentralized way, because you don't want everyone to be able to edit anything, right? You only want to give permissions to some people to edit certain things. Doing this permissions and identity in a decentralized way was really difficult to do. Like, there hadn't been any research done yet on how to do this. So because this was so difficult, every web browser that came after the first one took it out and focused purely on read-only web. So that's the reason why initially, like the first years of the web, all websites were mainly static. And if you wanted to change something on the web, you actually had to dive into the source code yourself, make the changes there, and then push it again to a web server. So initially, the web was read-only. Now, then a bit later, around the year 1999, the so-called Web 2.0 wave came in. And this was around the time where the first social networks and so on popped up, where people started to generate their own content. So in that sense, it was really important that people were able to write again to the web, so to create posts or to edit certain content. For this, the problem of decentralized identity was still not solved, but people needed it. So the way websites solved it then, or web applications solved it then, was in a centralized way. So each web application basically invented their own system for editing, which basically involved like requiring users to register on a website, log in, and so on. So the process we are all familiar of. But the thing is, all of these systems did it in their own centralized way, which meant that these systems were not interoperable. Like, for example, if you have an account on LinkedIn, you cannot use this account on Facebook or Twitter in an easy way. And also your content is also fixed in these different places. So this led to the so-called data silos that we still have up until this day. So the thing is, these data silos and the centralization around it, it actually led to a bunch of problems. On this slide here, I list some of the bigger problems that we have due to centralized web applications. So first obvious problem is that people are not in control of their personal information because it's stored centrally at some company's web server, and you have to trust that they don't misuse your data in any way. Second problem is that of vendor lock-in, where companies are incentivized to make users really dependent on their products. Like vendor lock-in causes companies to make it difficult to reuse your data in different web applications. Like, for example, if you have an account on Facebook and you would like to start using another social network, well, you basically have to start from scratch. Your friends and your posts will still remain on Facebook. You cannot bring them with you to the other social network. And then the third problem is that of censorship and influence of content, where you are really in the hands of the company or the web application to decide what happens with your data, what kind of data you see, and so on. So there's no way, or it's difficult in centralized web applications to have any control over that. So yeah, in the recent years, many people were kind of getting worried with all of these problems, including the web's original inventor, Tim Berners-Lee. So that is why around the year 2016, he started the Solid project while he was working at MIT. So Solid was mainly meant as a course correction for the web to basically solve the problems that arose as a consequence of centralization. So Solid basically tries to push back the web to the original vision of a decentralized web. Then around 2 years later, the Interopt company was founded, also by Tim Berners-Lee together with John Bruce, basically as a commercial entity to drive the Solid ecosystem forward a bit more quickly. So just to clarify here, Solid is not owned by Interopt in any way. Interopt is just one of the companies that commercially pushes Solid forward. All right. So this was a bit of history behind Solid. Now, before we go over to the next part, maybe we can already have a couple of questions, if there are any.
Do you want to have a question?
Yes, we have a question. Thank you. Ruben, thank you very much for this first part. I had a question. You said that if you just go back to the last slide, that I don't know, Ruben, something like that, Interopt comes for pushing the Solid ecosystem as one of other commercial entities. Why was this necessary? What was the problems, and how was it conducted before, if it was not by commercial entities? And sorry, it's the part.
That's a good question. So so as I've mentioned, Solid was started around 2016, but the thing was, it was started at MIT, which is a university. So this was started as a research project. But the thing is, with research projects, they typically go forward very slowly because research typically isn't incentivized to make things happen very quickly. While in the commercial world, it's important that things go forward more quickly and that things actually work. So that was the main motivation for starting this company, to make it go forward a lot quicker. And Interopt is also not the only company doing this, of course. Like in Belgium here, you also have several companies actively working on the Solid ecosystem. Does that answer your question?
Yes. Yes, perfect. I may have one question. It's saying that by bringing back the web to a wide space, web platforms to the decentralized web away without a great visible resistance within the society. I'm only talking from my point of view. And my question was, do you think that some issues like centralization and this decentralization of the web get popular once we lose them?
I'm not sure if I fully understand your question. So if I understand correctly, your question is if we go back to a more decentralized web, that people will be excited about this, or
No, I was just thinking out loud, and I was observing that sometimes I don't remember having observed great resistance against the centralization of the web in the early 2000s, and now it gets way more popular in the society. And I was wondering if we I'm not talking about people like Tim Berners-Lee, of course, but maybe we had a sense of the value of and the consequences of centralized web just after having lost it. And so my question was, is it something that you are used to observe, that some concepts are bringing back to the current issues once we lose it?
Yeah, so yeah, as you said, it can be difficult to know what you have until you lose it, indeed. So the web originally was decentralized, but I think at the beginning, many people did not really realize that it was decentralized. And then people started building at the web in ways that may have not been fully in adherence to the original decentralized vision of the web. Like the first social networks, for example, they implemented centralized identity and permission. So they may have, of course, they had good intentions, but they did not realize that by implementing it in a centralized way like that, that it was not really according to the original decentralized web principles. And I think, yeah, I think that really is like identity and permission. That is really the key part here. Once we get that in a decentralized way, people will be able to more easily build on a decentralized web. And then another thing I wanted to reply to, the fact that the original web was decentralized is also the reason why it became so popular, because there is no central point of control. So anyone could start building at the web and connect to it in any way they want. So that's the reason why the web grew so big. So if we want the web to be able to grow, yeah, more forward, then it has to be in a decentralized way, in my opinion.
Okay, thank you. No question? Does anyone want to ask a question? It's okay. I think we can go along.
All right. So now let's have a very quick look at how Solid actually works. For that, we'll have a look at three things. First, we'll have a look at the so-called personal data pods, which are places to store data. Then we'll have a look at what the implications of these pods are, and mainly what the implications for applications are. And then we'll have a look at standards, which are very important for Solid to make everything interoperable. But first, personal data pods. So within Solid, you are in full control over where and how your pod is stored and who can access it. Like in this figure here, you can see different people owning different data pods, and they can be connected in any way. And the thing is, with these personal data pods, you can basically see them as like vaults, digital vaults, in which you can store any kind of data. So you can store your personal data in here, like your name, your phone number, your email address. You can also store pictures in there, links to your friends, maybe calendar invites, and so on. So anything really can be stored in your personal data pod. Now, this concept of a personal data pod is quite simple. Anyone can imagine it, but it has some very big implications on how applications will be built. Because the thing is, within Solid, data becomes decoupled from applications. Because the thing is, today, data and application is always tightly coupled. Like on the left-hand side of the figure here, you can see a typical centralized application. Imagine something like Facebook, where all of the data of the different users is essentially part of the application. So it's really difficult to move the data out of there. So you have no choice of how your data is stored and who can access it. It's really up to the application to decide that in centralized applications. But with Solid, you have this decoupling of data and application, where applications actually stand separately from the data and the data pods, so that applications actually now require access or require permission from you, the user, to tell it that it can access, so read and write certain data. So this brings a very significant paradigm shift in how applications are designed and developed, because applications now have to take into account that the storage of data can be decentralized because data is now stored in the different personal data pods of the users instead of directly within a certain application. And applications also have to take into account that they may have to combine data from multiple data pods. So they have to look up data in different places. And next to that, there's also the issue of explicit access control. So applications cannot just assume that they can do everything with the data anymore. They have to ask explicit permission to the users to view or modify parts of the data. So these are very significant changes in how applications are designed. But for the user, this is all very good news, of course, because they gain a lot of freedom in how they use and choose applications. Because with Solid, since data is decoupled from applications, data can actually now be used by different applications. Imagine, for example, again, the example of Facebook. Imagine you have a decentralized version of Facebook on top of Solid. Well, your data would be stored in your data pods. So if you don't like this decentralized social network application anymore, you can just start using another application with your same data. So your friends are still there, your posts are still there, and you can even interact with people using different applications. So all of that is because data and application is decoupled from each other. And this is also very good news for application developers, because this means that this can lead to more innovation from people who make applications, because they don't have to focus anymore on really collecting all of the data. They can assume that some data already exists, and they can just start building applications on top of that, which means that application developers can focus more on user experience instead of data collection. So yeah, these were the main implications on applications. Another thing I want to talk a bit about are open standards. So on this slide here, you can see a screenshot of the so-called linked data platform specification. So this is an open standard, one of the standards that Solid actually uses. So this standard was basically created by a large group of people working to solve a specific problem. So this specification exists on the web. It's just a web page. Anyone can read it, but since it's open, anyone can also implement it. So the specification is not private or anything, or has a specific copyright. Anyone is free to do or use it however they want. So you may be wondering why Solid focuses so much on open standards. Well, the reason is it's aligned with the current web standards. because the original web is also built on open standards. That's part of the reason why it became so popular. But these open standards are also not proprietary, which means that anyone can implement these standards, so that there can be different implementations of them. So that there can be different implementation of solid pods, solid applications, and so on. And the thing is, if you have different implementations, you have more competition between the different implementations, which leads to more innovation, which in the end is always better for the end users. And since the standards are open, everyone can contribute to them. So if any of the people here would like to contribute to the standards, that's perfectly possible. So one last slide to finish this part. I want to emphasize that Solid should not be seen as a platform or an application. It's more like an ecosystem. It's essentially a collection of open standards just to make data pods and applications interoperable with each other. So Solid is not owned by anyone, which means that any individual, company, or organization can start using Solid and building things on top of it. All right, so that's everything I wanted to say about how Solid works. If there are any questions about that part, I guess now is a good time to...
Yes, we have a question. Yeah, me again, sorry. I wanted to know where the pod name comes from. I know the term from Kubernetes, and I don't think it's the same concept or referring to the same things. That was the first question, to what it refers exactly. And the second question I have is, how do applications know what users or pod users have of data? I mean, sorry, it was Englishly wrong, but so that they are able to imagine services, applications. Do they have to ask for access of all data, which would be so much confidential, nice? So that was the question. Do they have access to metadata or what? How does it work more precisely? Thank you very much.
Yeah. So for your first question, the name pod actually comes from, it's actually an abbreviation. POD stands for Personal Online Data Store. So that's where it comes from. And then for your second question, so how applications can find data, that's actually a really interesting question, and that actually summarizes the research I'm also doing day to day. There are a bunch of ways in how Solid applications can find data within pods. So as you said, permission is an important element in here. So the thing is, in solid pods, if you store something in a solid pod, you typically also will configure who can see it and who can access it or update it and so on. So for example, you could have a directory in your solid pod named public, so that everything you put in there is public for everyone to see. Like your name, for example, could be useful to put in there. Then you could also have a directory private, in which you can store things that no one is able to see. So if an application then wants to use your or connects to your solid pod, by default, it will be able to find everything in your public directory, because you configured this to be visible to everyone. But it will not see this private directory, because only you can see it. Unless, of course, you log in to this application with your solid identity, and you tell the application that it can actually see this data. So in that sense, applications will not be able to find data unless you explicitly give permission for that. Does that answer your question?
Yes, perfectly well, the second one, but the first one was also not only the acronym POPOD for personal online data. Thank you. But what is it made of? I mean, I'm a user. What do I need to have this pod? It's my computer. It's a data center, not data center. I mean, productive infrastructure. What do I need?
Yeah.
And then what is this directory of etc. Thank you.
Yeah, so it's I will actually give you more details about that in the next part of the presentation. So maybe we can go over to that part unless there are any other questions, and maybe afterwards, if it's still not clear, we can go back to this question, if that's okay.
Yes, we have other questions.
I have two questions, and if it's not a good case, or we can answer them later. So my first question is, are there already people or companies who would use Solid? And my other question is, as a user, if I have my Solid pod, do I need to have skills, technical skills to use this and to put data in it? And is there any standardized structure in order for the services that will use my pod to if it was very clear?
So for the first question, if I remember correctly, was if people are actually using Solid today. Yes, but it's mainly companies and researchers at the moment. So as I will also explain in the next couple of slides, Solid is still actively being worked on. So some of the foundational work for Solid needs some finishing. It needs some more work to be practically useful in the real world. But it can actually already be used, and many companies today worldwide are already starting to get into Solid because some of the important parts of Solid are already working. Like for example, how to set up your Solid pod. That already works. So there are companies working on implementations of pods. They are working on services where people can create a Solid identity and host their pod and so on. But on the other hand, things like how to effectively find data in an efficient way in your pod, this is something that still needs some work. But I'll talk about this some more later as well. It's mainly like individuals are not really using Solid yet. As far as I'm aware, it's mainly for experimenting and making proof of concepts, so things like that. But then the second question, I did not fully understand that. Could you perhaps rephrase it?
I try to explain better. I don't really understand what. There are two questions in my question. The first one is, if I want to have my bots as a user, do I need to have technical skills to use it properly? And the second part of the question is, I don't understand. Is there like standardized way of putting my data in my pod so that services can access it and use it in a practical way, I guess?
Yeah. So there are. So you don't require like really technical skills to set up your own pod. In the next couple of slides, I will show you some examples, some different ways in which you can create your pod. But I'll give you the details of that later. And for actually storing data in your Solid pod, the goal of that is that you also don't require any technical skills at all. It's mainly the applications that will have to make that as user-friendly as possible. So the idea would be that you if you, for example, would like to store pictures in your solid pod, that you would have like a pictures application in which you can log in with your solid identity. And this application will, in the background, connect to your solid pod. And then you could, for example, drag and drop your pictures into this application, and then the application will make sure that it's stored correctly in your solid pod. So yeah, solid will not require any technical skills. But if you have very technical skills, then you will, of course, be able to do other things as well with solid, but that won't be required in any way. Is that clear?
Yes, it is.
I think we don't have any more questions. No, we have one, sorry.
All right.
Question about Solid. If anyone can implement new standards, how does Solid ensure the interoperability between open standards?
Well, so you say that anyone can implement this standard. It's not really that. Anyone can implement software according to a standard. So as long as, like, for example, the standard I showed you here, this is a standard that Solid makes use of. So this describes how systems that want to implement these standards should interact with each other. So if I create a software tool that implements this standard, and there's someone else that implements the same standard, but in using a different programming language or something, as long as we implement the same standard, our systems will be able to communicate with each other. So that is how Solid ensures that all systems will remain interoperable with each other. So through these standards. So these standards are like a minimal contract that every application within the Solid ecosystem has to comply to. But as long as the systems comply to these contracts, you can implement it in any way you want.
Okay, thanks.
All right, then I guess we can go over to the final part of this presentation. So in this part, I want to talk a bit more about standards and the work Solid is doing at the moment within this context. Then I want to also talk a bit about creating personal data pods, like how you set up your own pod or how you can implement your own pod if you want. And then in the final part, let's also have a look at really how Solid applications are built and what some of the things are that are still needed to make this work in practice. But let's start with standards. So as of today, Solid makes use of a couple of foundational standards that are already in place. So these are standards related to how data must be represented, how you can query data, how data must be published on the web. And these standards, they have existed already for a couple of years. They work well, and they do what they have to do. But there are a couple of other standards that are still a work in progress. So these are things related to authentication and authorization, also cryptographic signatures, and so on. So people are actively working on these standards, but the standards are not fully finished yet. So there are some prototypical implementations of them. So you can actually already start using them, but yeah, everything is still a bit in flux before they are really finalized. So the way these standards are being worked on is through the so-called World Wide Web Consortium, or W3C. So this is actually an international standards organization for the web. So all of the web technologies that we already know, like how web browsers connect to the web and so on, these standards are also created by W3C. So this organization has been around for a while already. It was founded in 1994 by Tim Berners-Lee. and it works on a very large amount of web-related standards. So within W3C, you have the so-called Solid Community Group. This is a Solid specific group with hundreds of members worldwide, spanning different companies, organizations, and universities. So it's really a diverse group of people with different interests and goals. And within this Solid Community Group, you have different panels, where each panel has a different focus. Like you could have a panel on authentication and authorization, you could have another panel on interoperability, and so on. And they all work on their own parts of the standards then. So this community group is fully open, so you can visit it on this link. So anyone who wants can actively contribute to this group and work on the standards. So that was everything I wanted to say about standards. Let me now talk a bit about solid pods. So the thing is, so since Solid is based on standards, there can be different implementations of a Solid pod. So as of today, there are actually different parties actively developing different Solid server or Solid pod implementations. Like for example, we have the Solid Community Server. This is a fully open source implementation of a Solid pod. Can be downloaded via this link. Next to that, also notable is the Enterprise Solid Server. This is a commercial implementation of a Solid pod by the Interrupt company I mentioned earlier. This is mainly useful for enterprise level pods. So for companies that want really strong service level agreements, for example, to make sure that their pod is always available. But yeah, I mentioned just 2 Solid pods here, but since the standards are open, anyone can implement their own Solid pod if they want. And on this link here, you can see a couple of alternative implementations. So next to choosing your Solid pod implementation, you can also choose the location of where your pod is located. So you can, for example, decide to download the community Solid server since it's open source and set it up on your own machine locally. That gives you a lot of advantages because you are in full control over your pod and how it runs and so on. But you also require the technical skills, of course, to be able to set this up. And you are also responsible for making sure that your pod stays online. So your computer, if it crashes, then you have to fix it manually and so on. So a lot of flexibility, but also responsibility. If you do not want to go through the effort of setting up your pod or you don't have the technical skills for that, you can also make use of free hosting. For example, solidcommunity.net allows people to register for a free pod. But the downside of that is that since it's free, it has some limitations. Like solidcommunity.net limits the amount of disk space you can use in your pod. If you don't like these limitations and you still don't want to self-host your pod, you can also decide to rent hosting. In that case, you can actually pay a web server to host your pod, and that way you pay for less limitations and also perhaps even guaranteed availability. So yeah, you are free to choose how or where your pod is located. Then one final thing I want to focus on a bit is solid applications. So the thing is, applications in Solid will be quite different compared to the traditional centralized applications, because in Solid applications we'll have to be able to access data from multiple pods. Because centralized applications, as we know them today, always assume or typically assume data from a single data source. And the techniques that we need for retrieving data from a single location are relatively simple. And we already have decades of research done to make sure that we can do this in a really efficient way. But in the future, with Solid's decentralized applications, these applications will have to be able to combine data from across multiple data sources. And yeah, we don't really know that well how to do that in a very efficient way yet. Like, we have techniques to do it, but they are not as good yet as the techniques for retrieving data from a centralized place. But let me give you a concrete example of what I mean by that. So let's assume we have a centralized social network application where data is assumed to be located in a single place. Like, for example, a social network application stores data related to posts from people. It stores likes from people, comments on these posts, and so on. And all of these things, so the posts, the comments, and the likes, are all stored basically in the same database, right? So it's really simple for an application to visualize everything. It just has to find data from a single place. But if you have the same application, but it's decentralized, then it has to be able to access all of this data from multiple locations. So in the worst case, all of these different data elements, like the posts, the comments, and the likes, can be stored in different places. Like, imagine if you have like 100 friends, each friend has like 10 posts, which already brings us up to 1,000 posts in total. Maybe there are 10,000 comments, maybe 100,000 likes. So if all of this is stored in different places, you quickly come to a very huge number of data sources that you need to be able to access. So then the question becomes, how can you efficiently find data across this massive number of data sources? And the thing is, this is the area where there are still a lot of open research questions. So these are also things that we as researchers are actively working on to figure out how to solve this. So these are questions related to how can you find data pods on the fly? Because in Solid, everything is decentralized. So you don't know beforehand where everyone's data pod is located. You have to find them dynamically on the fly. Then there's also the question of prioritization and parallelization, because if you need to be able to access multiple data sources, yeah, you cannot visit all of them at the same time. You have to maybe prioritize access to some of them first. Like, for example, you may decide to first access data from your friends and then from your family, or the other way around. Depends what your preferences are. And then there's also the issue of complexity. Like, if you want to build an application for Solid, yeah, you don't want to reinvent the wheel every time and re-implement this complex process of finding data across this massive number of sources. So we need reusable software libraries that are able to find this information for you in an efficient way. So yeah, these are some of the open questions we still have up until this day. So this was everything I wanted to tell you about the open challenges for Solid. I just have one more slide where I just want to quickly summarize the essence of this presentation. So in summary, Solid is a project that aims to re-decentralize the web. So to go back to the original vision of decentralization. Solid does this by giving everyone a so-called personal data pod, which is in full control of the user. And one of the implications of these pods are that data become decoupled from applications, which means that applications now have to ask permission from you to access your data. Solid does this by being built on open standards, which means that anyone can implement parts of the Solid ecosystem, basically. And as I've said in the last part, there are several open challenges still within Solid, but anyone is welcome to contribute to them since Solid is open. All right, so this was everything I wanted to talk about. I guess we can go over to the final set of questions.
Thank you, Ruben, for your rich and interesting intervention, which is a perfect complement to the previous ones we had this week. The students of the master are very grateful for your participation in our event. And we would like to thank you warmly for the time you have given to us today. Now, if there is any question in the audience or in the Twitch chat, no?
Yeah.
Yes, we have one question in the audience.
Thank you very much, because the presentation was really clear. Two questions. The first one is, did you come to the idea, or is it possible to think about some centralization, not in technical and at a technical level, but logical? For example, to reach for the, like, we use this term, annuaire, I would say in English, the index of all the pods, sorry, and so what kind of to declare what kind of data in which structures there are in each pods. Maybe logical centralization could be helpful, not in a technical way of thinking, but for example, blockchain. I'm not saying that blockchain should be useful here, but blockchain is decentralized, but put logical centralization so that everyone can see the same thing, access it in an ordered manner, etc. So that was a question I had. Or how do you see solving this problem actually? Because I could think I understand that it's a research question that you are working on actively. And the second question was, did you imagine the possibility of pods communicating together directly, not via app developers, but individuals to individuals, like in a kind of traditional peer-to-peer system? So I'd like to access the data of my sister, the photos on her pod, and I can read and write even. I don't know if it was a kind of future you envision or you build on. So this is it.
All right, thank you for the questions. So for the first one, so basically the role about centralization within Solid. So the thing is, since like we over the last couple of years, since we have many centralized applications already, we know a lot about centralization already. So centralized data access, we know a lot about that. So you make a good point that we can learn a lot about these techniques to help us within the decentralized web. So the thing is, indeed, some kind of centralized access of pods, for example, would make sense to speed up data access in certain ways. But instead of really centralizing this index, like the terminology we prefer to use there is more like aggregation instead of indexing. Instead of centralization, because in centralization, it's really this central system that manages everything. But with aggregation, you could have basically multiple different centralized places of interest. Like, for example, one of the areas in which we are doing research is in aggregating certain data by topic across a group of solid pods. Like, imagine, for example, you have like your whole family has a solid pod, and you have a social network application that wants to visualize the posts from your family. In that case, it might make sense to set up a central aggregator service between the pods of your family, so that data relevant for your family could be aggregated in a central place, so that if you, for example, use this social network application, it will first have a look at the centralized aggregator service to see if there are any posts from people within your family, and it will first use that aggregation service to populate the data within this view of the application. And only if the application does not find any aggregation service, it will have to request each solid pod separately, which will slow down things, but it will still work. So the thing is, with solid, we assume that decentralization, so everything in a different place, is the basis. So everything should still be able to work in a decentralized way. And if we notice that things become too slow when it's fully decentralized, we can start aggregating something, so centralizing some parts of it, really. And these centralized places can act as optimizations for speeding up everything within Solid. Does that answer your first question?
Yes, pretty much. One bémol, virgule, comma, was to ask why a decentralized system in the sense of blockchain, not blockchain per se, but the system it represents, wouldn't be useful in your case, in the Solid project case. And I was talking about centralization, but not in a technical way, but in a logical way. So blockchain set logical centralization, meaning that everyone sees the same thing in the same order. That's centralization, but at the logical level. And it is useful to people to share the visibility of something. It's consensus, I mean. And maybe for the index and for the kind of data structures of each pod or a group of pods, this kind of technologies or way of doing could be useful. And I was just wondering if it was something that was thought about, but I have to say that the aggregation was really interesting. So thank you already.
So you mentioned logical centralization. So and you give the example of blockchain. So blockchain could in fact be useful for Solid. It's not something I'm working on myself, but I'm sure that there are people actively investigating this. But I don't know specifically what the details behind that are, but I'm sure it's being worked on by someone. But the topic of logical centralization, I think it's actually a very good point, because to me, logical centralization will actually be, or at least virtual centralization will be crucial for making it easy for application developers to build applications on top of Solid. So the slide I had here, so in the last part, I mentioned that we need to be able to hide complexities for finding data from application developers. Otherwise, it will be too difficult for people to create applications on top of Solid. So in that sense, I think for an application developer, it should basically feel as if it is accessing data from a centralized place. But in the background, well, this is all just virtual. So in the background, it will still, or some kind of software library will still access all of the data that exists decentralized, but it will feel as if it's centralized to the application developer. So was this what you were hinting at in your question?
Exactly. Thank you very much.
Okay, perfect. Did you have a last question as well?
Yeah, could we please stay on this slide? I may have a question about prioritization of data. I was wondering, does this data prioritization mean that you will have to build up a kind of hierarchy between this data, to organize them and to create something that, yeah, a kind of hierarchy between data built on relying on the data nature or the relevancy to the request or something like that.
Yeah, indeed, like there could indeed be hierarchies of types of data or perhaps locations of data that you want to prioritize. Like for example, I gave before was that you might prioritize data from friends over data from family or the other way around. But what you could also do is indicate the priorities of the data that you trust. Like for example, if you would have like some kind of news application within Solid that collects data from different news organizations. What you can do then, or at least in theory, this does not exist in any way yet, but what you could do in theory is you could configure in your Solid profile, for example, that you say, okay, I first prioritize news from this news organization because I trust this one the most. If I don't find anything related or for the topic I'm looking for within there, then you can start looking at this other news organization, and you can have this like list of trusted sources where you can find data. But yeah, all of this is still pretty much under research. So all of this does not exist yet.
Thanks a lot. Any other question? Okay. So once again, many thanks for.
No.
Okay, another
We
question.
have a question.
One last question.
I'm sorry, this will be my last, and it was, I already asked it, but we lost it in memory. It was about the pod-to-pod communication. Will this be a future that we might envision in this Solid project?
So yeah, indeed, we forgot about that question before. So pod-to-pod communication and also peer-to-peer communication in that sense, it could be interesting to have a look at that indeed. I'm not aware of any active work in that area. But there is at least work in the area of peer-to-peer within Solid applications. So the thing is, and I'll go back to this slide, finding data is complex. So finding data in the background within Solid applications, this is a complex task. But what you could do if you, like I'll give the example of a social network again. If you have a social network and you have posts of your family, if your family members are using that same social network application, you could actually set up a peer-to-peer connection between the different family members so that this task of finding data is actually shared between the different people in your family, because chances are big that you are probably retrieving very similar data from certain places. So in that sense, you could share in the computation for finding this data in between these different family members. So for example, if I have already found some data about some people or made some, the application has made some calculations or derivations from certain data, I could share it with other people in my family if they want to retrieve similar data. Does this answer your question about about connecting pods and peer-to-peer.
Thank you. I'm looking forward to have the chance to hear about Solid project in a few years. We will have move on the challenges and perspectives, but it's stimulating.
Any question? Okay, so once again, many thanks, Ruben, for your presentation. We wish you the best, and we hope to keep hearing good news from you and from Solid projects. I think we can end this session.
All right. Thank you all for your attention and being able to present here.
On reste sur Twitch.
Bye. Thank you.
Bye.
À tous ceux qui sont encore sur Twitch connectés avec nous, nous allons vous retrouver d'ici quelques minutes après une courte pause à 16h avec Monsieur Thomas Gentilhomme qui nous parlera à 15h. J'ai dit 16h?
Oui.
Pardon, à 15h avec Monsieur Thomas Gentilhomme qui nous parlera de la métaverse et du DAO. À tout à l'heure. C'est bon, c'est parti.